Scintillate, scintillate, asteroid malefic. Fain would I fathom thy nature specific. Loftily poised in the ether capacious, strongly resembling a jump carbonaceous. Scintillate, scintillate, asteroid malefic. Fain would I fathom thy nature specific. When we look at the night sky, we get to see many bright objects drifting away there with a black drop. So few of them are stars, a handful of them are planets. But what do the others represent? Well, they're actually satellites. From Starlinks to International Space Station, we get to see many artificial satellites drifting above us in the night sky. And who had wondered 1,000 years ago that something that is man-made would one day decorate the realms of heaven? That is something. Well, it is interesting that the word satellite in the 16th century, it used to mean that a person who was an attendant or a subordinate to a superior person. Well, it was not very late that this particular term caught on to astronomy to refer to those objects which used to orbit around a very bigger or massive space objects. Well, coming to, while we are on the topic about satellites, let me tell you something. There is no specific definition as to what a satellite is. Any subordinate object that orbits around a superior object is referred to as a satellite. Earth has Moon as its natural satellite, and it has a myriad artificial satellites. Did you know that Moon also has artificial satellites going around it? Well, we have the lunar orbiter, we have the Chandrayaan. All these orbiters that orbit around Moon are the satellites of Moon. And also, it's not just our Earth that has artificial satellites. We have artificial satellites orbiting Mars too. The Mars Orbiter mission, most commonly called as Mangalyaan or the MOM, along with the Maven aircraft by Maven orbiter by NASA, even they are also artificial satellites of Mars. Well, we have come to that stage and technology wherein we are sending out artificial satellites to orbit somewhere beyond our own world. Isn't that amazing? Oh, sorry, I forgot to welcome you all. Please pardon me. Well, a warm welcome to you all to the World Space Week 2020 by SSERD, a week-long celebration of the saga of satellites and how satellites improve life. From International Space Station, which is the largest satellite orbiting around the Earth, which basically is a space settlement for us to step forward to and look forward to constructing more space settlements in our words to the space age. We have Hubble Space Telescopes, we have the GPS constellation, we have the upcoming Starlink constellations. Well, the way these satellites have revolutionized our modern day life, it's impossible to capture those things in words. So this year's theme, that is satellites improve life, is to shed light upon how satellites launched starting way back from 1957 up till date have been revolutionizing our life. Well, let me also point it out that the concept of satellites, it all started out with a thought experiment by Sir Isaac Newton in the 17th century. His famous thought experiment of cannonballs as to what height one has to go and at what velocity one has to throw, such that a particular object, when being thrown out, and if the Earth's curvature would match its parabolic trajectory, voila, you have an orbit. So that is where the dream of the satellite started, and it was realized in 1957 on this very day. So it's approximately 63 years that Sputnik 1, the first artificial satellite, was launched. We celebrate World Space Week every year to commemorate this particular event. That is the first artificial satellite sent out to space. From October 4th to October 10th, we celebrate the World Space Week. In this spirit, we at SSERD have organized the World Space Week 2020 with keynotes, workshops, and fun-filled competitions for you all to celebrate the spirit of space science with us. So let's proceed with the inauguration ceremony. Now, I would like to call Mr. Sujay Sridhar, who is the chairman of SSERD, To tell us more about World Space Week and how satellites have revolutionized our life. The topic, the theme of this year being satellites improve our life. So, Sujay, can we have you on screen and let us know more about this year's theme?
Hey, thank you, Tejas. Thank you so much for the introduction. And first of all, I would like to welcome you all for this World Space Week celebration. As Tejas was mentioning earlier, so we celebrate World Space Week in the light of we launching our first artificial satellite. So in 1957, we launched our first ever satellite, artificial satellite. Until then, we had just the moon, right? So the first satellite was called Sputnik 1, and the satellite didn't do much. It's just sent out some Morse code, or it's dots and dashes or beeps from the satellite. It was sending out to the ground. Now we have most advanced satellites studying the other planetary bodies. So from there till here, we've been relying upon the satellite extensively. So this year's World Space Week. So World Space Week happens because of this reason. So we launched a satellite into space, and then we became something like a spacefaring civilization, right? Okay. So satellites are a very important part of our life. So that is why this year's topic is satellite improves life. Now, coming back to how, I mean, I do get the question. So when we talk about satellite, when we teach about satellites, when we launch a new satellite into Mars, right? We get a lot of questions. Why are we doing? Why we are spending this much of money? Why are we investing a lot in space when we can solve the poverty by spending that much money? Because I do remember when we had Mangalyaan launch. At that time, every politician in our country was asking, why are you spending 400 crores to sending a satellite to Mars? And why can't we use that 400 crores to solve the problems in here on Earth? Now, the thing which people don't really realize is from the day morning when you wake up till the time you sleep, you are relying on satellites. So let me just tell my routine. I get up in the morning, I have my tea, I open my newspaper. There, for getting that news on the newspaper people are actually realizing on satellites to transmit the data. Now, coming, okay, I turn on the TV, I'm seeing the TV. The signal, where it is coming from, that is from a satellite, right? I open my WhatsApp, I'm checking out, there is a satellite involved somewhere in between where they're sending the data. Okay, let's come back. Now next, I'm just going out with my friends, I'm going to a restaurant, I'm having my food, I have to pay through my card, or I have to withdraw my card money from the ATM. How is that possible? That's because satellite. You must have seen an antenna on top of every ATM, right there, right? So basically, the ATMs are using the signals from space. Now, coming back to this, every aspect of your life, from your TV to your financial, your bank is using. You're going out. You need to book a car. How do your cab driver realize where you are? It's basically using the navigation satellites. So coming A to Z of your life, it is being used. I mean, the satellites are being used for every aspect of our life. That is why this year we have something called Satellite Improves the Life. Now, coming back to this, so this year we have planned out, like we've been doing World Space Week celebration from the beginning, and we've been doing a lot of offline programs this year. Since all this corona is happening, we are doing the World Peace program online, and we have arranged a lot of workshops, interesting workshops. You must have not realized how much we are depending on satellite, how much data you can get, what all you can do with the satellite. So we have devised all that all that thought we have put into our head, and we are bringing you all various workshops so that you will understand and you can appreciate how much effort and how much satellites are really helping you out in your day-to-day life. So coming today, we have a talk on how satellite data can be used and how it is used. So it's obvious that we know it, but we will be able to appreciate more when we understand more how satellite is affecting our daily life. So, being that, I would like to welcome you all. Thank you all for being here and attending our sessions. I hope you all enjoy it. And yes, thank you, everyone. Over to you, Tejas.
Thank you so much, Sujai, for those wonderful words on about the topic of theme for this year, that is satellites improve life. Well, as you were talking about how we use satellites, like how we interact with the satellite technology in our day-to-day life. I mean, like yesterday, I wanted to search for a particular cafe, like a new bookstore, to purchase a book, and I also wanted to look for a cafe that is more safe and maintains all the social distancing. So in order to do that, I had to use the Google Maps. So the data for that actually comes from geotagging, and the the most of the crowd data sourcing that happens, all the feedbacks that people pour in, and all this data being relayed up from the satellites to my phone. I mean, if it was somewhere like 20 or 30 years back, who would have known? How would I have searched for a cafe that would maintain social distancing? And also the online classes that are happening right now, like all of us, we stay at the comfort of our place and studying at our homes, listening to our professors, their lectures, and also this very particular event which is happening virtually, all thanks to the satellite technology. I mean, imagine this: had we had not had this particular satellite technology that we are having right now, how would we be able to manage this pandemic situation? I mean, the whole system would have halted. We can't even imagine the system functioning right now as it is functioning today if it were not for the satellite technology. I really thank you for those wonderful words on how satellites have made a positive impact on our life. And now I invite Ms. Nikita on the screen, CEO of SSERD, to tell us more about the activities that SSERD has been doing for the past few years on satellites, and how we are educating the students about the satellite technology and increasing awareness about the space technology. Nikita, the screen is yours.
Thank you very much, Tejas, and everyone. This is Nikita here, and very happy to interact with you all. I welcome you all for the World Space Week of this year. And so, Jai was telling you all about the program, or the theme of this year, which is actually Satellites Improve Life. It's so important that every part of our daily activities are connected to space. If I have to tell you all, like long back, like when I say long back, it's thousands of years back. Our ancestors were dependent on space technology. And let me not say space technology, but I can say space. For example, we used to use stars for navigation, and then we also were looking at the constellations to check if we are going in a right way or right direction. At the same time, we also used to see the sun and the moon to check out the timings, right? Like the shadow and all these things. I mean, space is not something um, or let's say new for us. It's been used from a long time now. Just that this, it's not just the space, it's the space technology that we are using right now in this generation. So Sujay gave a lot of examples. I would like to continue with few of the examples and then tell what I wanted to say. So yeah, Sujay stopped at the point where he went outside and he went to buy something and he paid by withdrawing money or he used his card. But I want to tell you few more things, probably continuing from there. So if I was a person there and suddenly it started raining and I had so many plans for the rest of the day, and how do I actually know if I should actually continue with my plan or go simply sit at home? So what I'm trying to say is we actually get to know the weather, right? So we can actually know what is going to be the weather with the help of the satellite data. At the same time, like if I have to go from one place to another place, again I use the map, and you know how good it is in the current situation. Like it just doesn't tell you the route to your to the place where you want to go by walk. not just by walk, but also through your two-wheeler or four-wheeler. I mean, it just gives you a lot of multiple options to take, right? That's how intelligent our satellites or satellite data has become. To go little more forward, which we all might be thinking, okay, satellites are something that only a person who's educated or a person who is doing a white collar job needs the satellite data. The answer is not, because a very common to common people, like a farmer, like a fisherman uh, does also use space technology. If you are wondering how, for example, farmers can use the space technology as in satellite data to check what is this land that he is using, and know what is the mineral it contains, or water content that of that land. And with all these intelligence, like we have artificial intelligence and all this could be merged to check or to predict and tell the farmer which crop to be grown on his particular land in particular month, which gives him the intern data of, okay, if he grows so and so particular crop, this would be his um, profit. Or he could take loans from so and so banks, or in fact that are there right now today. In fact, now coming to fisherman, the satellite data could provide the fisherman where exactly he could find the more or the quantity of the fishes. So he goes exactly to that location and fishes it, right? Like how cool is that idea? So things like this, each one of us use or could use. It's just that we need to think how we could use space technology, or particularly satellite data, um, for for doing our daily activities. Now let's forget about daily activities, something that unusual happened. Where all could we use satellite data? You're going to learn throughout this whole week, but I thought let me just give you the glimpses of it. For example, we use satellite data for urbanization, for example, where the more buildings are coming up, or where the city is getting extended, or how the water is getting depleted. In fact, we could also see the level of water content decreasing in the city region. At the same time, in the polar region, how the water quantity is increasing by the climate action. And you can actually think of, someone is actually looking at our earth all the time, and that data we could use it to, for a better reason, for a better purpose, right? So that's the theme of this year: satellites improve life. At the same time, you can also think of satellites being used to look outside the earth, right? For example, the moon or the Mars, or look out what all developments we have seen, finding out the water on moon or Mars. In fact, finding out the extraterrestrial bodies that we have, like we found so many exoplanets which could be similar to our Earth. It's all possible because of our satellites. Anyways, you will be learning a lot throughout this week, but let me take you through the presentation that I've made, which actually explains what SSERD has done in the field of satellites to the students, being a space educational organization. So let's go to the next slide. So satellites were always important for us, and we always wanted students to know what is it's important, and what major role it plays. Can we go to the next slide? Yeah, so next. As you all know, the objective of SSRD is to promote space education among the community, and I have said everything that we do, but let me take you to the next slide again. Yeah. So I was telling you what all we have done, and this is just an overview of we being a small, like a tiny part of this huge universe. We have gone from Earth to Moon to Mars to Jupiter, to Saturn. In fact, we've also gone close to the sun. And you know that there are three non-living things that has literally crossed our solar system, and they belong to satellite, family. And all these missions have let us explore this whole universe, and this doesn't stop here. We're gonna go forward in exploring a lot and lot. Keeping this as one of the motive, we wanted students to understand the importance of satellites and its applications, and we started off with the workshops. Can we go to the next slide? And we give in the form of we've organized many CANSAT workshops where students understand how exactly the satellite work. And this particular model that you're seeing, they actually don't go to space or perform any experiment. It's a small model of a CubeSat, or let's say CANSAT, which actually collects some data, like it senses some data, and you program it in such a way that you read those data, which means you basically need to have a system where so it collects the data and gives you back the data. So these are the workshops, like we've conducted many where not only school students have taken part, it's many college students have also taken part. And the outcome is amazing, that they learn how exactly the satellite works, and this should help them to build their own real satellite. Coming to satellites, we know that the next big thing is satellites used to be the size of very huge things, like an elephant, or like the size of a car. But if you look at the satellite size now which are coming, it's the size of a CubeSat. If you can see what's there now, it's like a 10 centimeter cube. Right now, what you see is a 3D printed cube, which we use to explain, but that's possible. That's the size of a satellites that are there in the sky right now, in the space right now. And we teach the students that this is possible. And this is not just possible by the scientists, but it's possible by students like most of you are. You can build one too, and that's what we tell students. Can we go to the next slide? Apart from the big things that we talk about, we also have a small kids at SSERD who try to learn and build their own satellite models, like what you can see now. There's one student who actually learned during our outreach program how a satellite works, and there was an activity on to build their own model of a satellite. It's a very beautiful model that they've made. Let's go next. Another student who built a small satellite out of paper. Amazing. Apart from that, we also had students dressed up like a satellite itself during the Children's Day. So it's amazing that we see how students are getting interested towards satellites and its applications. Let's go next. For us, SSERD, at SSERD, the satellites was one of the key thing to reach out to students and make them create curiosity among the students. So yes, we always had satellites as one of the topic whenever we used to have any of the internship or projects that we used to give. Let's go next. As a part of this project, we had around 5 students from a school called Oak Ridge International School. They actually wanted to build a satellite, and we said, to start off, I think we should develop a payload which could go to near space and you understand how exactly the satellites work. And this was a project which we planned, and these 5 students build this payload which went to near space, and we launched it through weather balloon with the help of Indian Institute of Astrophysics. And the students were able to collect the data of ozone, amount of ozone right here in the Bangalore, and they were able to do the analysis. They published the paper, and today we are so happy that they are they're studying in very distinguished universities outside, and they make us really proud. Can we go next? This is a group picture that you will see now of the 5 students. And it was 2 years back. The students were like they did amazing job. And previous year also we had another set of students. In fact, this was a government project actually, with in collaboration with the government of Telangana, where the students were made to again make a payload, and students made a payload which could again measure the ozone quantity. But here this time we launched it in a very huge balloon, like if you could see, that's TIFR balloons where we launched it. And we have a small clipping from the news. Let's watch it. The audio isn't coming. Can we try with audio?
సాంఘిక సంక్షేమ గురుకుల విద్యార్థులు మరోసారి సృజనాత్మక ప్రతిభను ప్రదర్శించారు. స్ట్రాటోస్పియర్లో వాతావరణాన్ని అధ్యయనం చేసే నమూనా శాటిలైట్ స్వేరోసాట్-1ను భూమి ఉపరితలంలోకి పంపించారు. ఓజోన్ సాంద్రత, రేడియేషన్ దుష్ప్రభావాలను అధ్యయనం చేసే లక్ష్యంతో టాటా ఇన్స్టిట్యూట్ ఆఫ్ ఫండమెంటల్ రీసెర్చ్ సహకారంతో దీన్ని రూపొందించారు. రాష్ట్రంలోని వివిధ సాంఘిక సంక్షేమ గురుకుల పాఠశాలలకు చెందిన 15 మంది విద్యార్థుల బృందం రాత్రి 2:45 సమయంలో TIFR ఆవరణలో గాల్లోకి పంపించారు. భూమి నుంచి స్ట్రాటోస్పియర్ వరకు సుమారు 4 గంటల పాటు ప్రయాణించి రేడియేషన్ ప్రభావం, ఓజోన్ సాంద్రతకు సంబంధించిన వివరాలను సేకరించింది. సుమారు 26 కిలోమీటర్ల అక్షాంశాలకు బలూన్ చేరుకుని అధ్యయనం చేసి వివరాలను గుల్బర్గాలోని TIFR కేంద్రానికి చేరవేసింది. విద్యార్థులను సంక్షేమ మంత్రి కొప్పుల ఈశ్వర్, గురుకుల సంక్షేమ సొసైటీ RS ప్రవీణ్ కుమార్ అభినందించారు.
For playing that clip. As you saw, this was in collaboration with the government of Telangana, where we had students from the schools, where it's Gurukula kind of school, and the students were able to understand how the satellite worked, and they made this payload by themselves after a lot of training, and we launched it. It was a grand success. We are very happy to be part of that project as well. Let's go next. We continue to work on that, and even today, like we have one of the topic as satellites. So these were the two teams which kind of worked on the satellite related. For example, micropros, they were developing the thrusters for the CubeSat. At the same time, Vulcans were the team which actually developed a scientific payload that could actually go and land on an asteroid and collect information or about the asteroid. So we always look for a satellite or related technology under IPD. So if you're interested, you could also join our IPD section, where you could do your internship on amazing projects. Where here I just mentioned about space, but we do have a lot of topics related to space. Let's go next. Apart from this, yes, we've not only helped students to understand how the satellite works, but also the applications part of it as a part of our Girls in STEM program, where we had around 33 girl students to come in and join and learn about the different applications of satellite, where the students were able to learn how to collect the satellite data, how to look the like actually understand which particular the antennas are in connection with particular satellites, and try to get data, how to use Google Maps, or let's say how to use the Earth observational data, how does the CubeSat work. Everything is a part of our Girls in STEM program as well. So yeah, this is one way that we have also taught about satellites and its applications to our students. And you can go and visit us or follow us on all the social media. And as I said, we have much more things coming up for this whole World Space Week program. Can we go next? We have planned for World Space Week. Tejas is going to explain a lot more as in what all we have planned for all of you. But yeah, this is World Space Week, which is basically about satellites improve life. We hope you'll make the best out of this program, and yeah, that's it from my end.
Thank you, Nikita, for those wonderful words and briefing about how SSERD is working towards, creating awareness about satellite technology. So, without delaying it much further, let's start our inaugural program. Let's proceed with our program on today's special keynote by Professor Arup Dasgupta, sir. And now I invite you back on the screen to introduce Arup, sir, to us. Nikita, if you could do the introduction.
Yes, it's again a very happy moment for us where we are going to introduce you all to our first speaker. In fact, to today's World Space Week program, and that's a very distinguished person. You must already have looked into his details, but let me also introduce in short about the speaker, today's speaker. So his name is Professor Arup Dasgupta, and he's right now working with the Geospatial World as a senior editor. And he has earlier worked into various sectors in space, and particularly in the space applications. So he's the experienced person to talk about how exactly we can use the satellites and satellite applications, or let's say space data. So sir, I don't want to take much of your time. In fact, I welcome you to our World Space Week program and request you to share your all the experience that you have with a very little time that we have. Thank you so much for accepting our request, and I request you to take over.
Thank you, Nikita. It's always a pleasure to talk to young people and talk to them about a topic which is very close to my heart, and that is space applications. Since we have a short time, so let's go ahead with the presentation. So the topic of my talk is taking space applications to the grassroots. What do I mean by that? Space applications are a very big arena, and earlier in the introduction you've heard about space applications, right, going from space exploration down to looking at space objects, and then finally looking down to the earth where we are very much firmly rooted. So that's why the topic of my talk is space applications to the grassroots. So the grassroots essentially are we the people, so to speak. Now, it's very interesting how ready are we all for the space applications. And this was a very interesting diagram which I found from an article on social life networks which appeared in IT Professional as an IEEE magazine in the November 2011 issue. So it's about 9 years old, but then the numbers can be taken, they change, but more or less the ratios will remain the same. So if you look at the top 1.5 billion people in the world, they are very savvy with technology, like all of us who are participating in this particular webinar. Then you have another 3 billion people who are in the middle, who have access to the technology, but they may not be using it as effectively as the top 1.5 million. But the real people to concentrate on are the bottom 2 billion. These are the people who are literally at the grassroots. They are the farmers, the workers, and these are the people who do not have access to this technology. And even if they have the access, they really will not know what to do with it. And that's basically going to be the theme of what I'm going to talk about. So if we look at some of the major space application technologies which are there with us today, the first one is the satellite communications, right? And we all are listening to our favorite programs on DTH and so forth. And that's basically where satellite communication comes in. But it has many more uses than just the DTH and telephony, telegraphy, and so forth. The second big technology which we are all familiar with is remote sensing, that is looking at the Earth from space, not only in the optical region, but also in the microwave region. And this helps us to understand about our Earth about what's the dynamics going on there. Somebody mentioned climate change. So yes, remote sensing is very useful for climate change, as also useful for monitoring crops, also useful for finding out water resources and so forth. The third technology is the navigation satellite services. Somebody mentioned again the IRNSS, so the NAVIC series of satellites, which is our own regional navigation satellite system, which is coming into use slowly. But then you're all familiar with the GPS and the other systems like the Chinese Beidou or the European Galileo and so forth. So these are the technologies which are available, and how can these be used? And this is shown in the next slide, which again I've picked up from a very interesting book called India in Space Between Utility and Geopolitics. It's published by Springer, and the author is Marco Aliberti. And you can see here some of the typical applications which have already been done, like, for example, remote medicine using telemedicine systems. This is used satellite communications. Teleeducation, of course, is very famous. Then we have even things like planning of at the very, a very detailed level at the panchayats, then training of people, training of teachers. Weather is again a very big application which we are very much into. Then of course you have a lot of other applications like watershed development, and then market information. This is again very important. Of late you heard about the problem that is there regarding the market yards, the APMC and the Farmers Acts and so forth. So market information, that's very important. Transferring this information swiftly. Then the most important problem, and we are into that decade of the water, as they say, because drinking water is becoming more and more of a problem for all of us. So how can satellites help there? So let me start with the first one, which is education. And this is called distance education. That is, you are training, you are sitting somewhere, and your students are sitting somewhere else, and you are able to teach them, right? So this was actually through something called the community TV, right? It's a little different from the what do you call the direct to home. This is direct to community. And the very first experiment in the world happened in India in 1975. That's practically prehistory, but let me talk about it because this was the project which I started my career on. It's called the Satellite Instruction Television Experiment, and in this picture that you see is one of the scenes where school children are watching programs on the TV. And on the right-hand side of the picture, you can see the antenna which is looking at the satellite. The satellite was the ATS-6 satellite of NASA, which they loaned to us for a year. And we spread out these kind of direct community TV receivers to about 2,400 villages. And we were able to then give them a 1-hour program on education in the morning and a 2-hour program in the evening for the adults. So this was how we started. And then, of course, we went on to other projects like GramSat, which is basically, again, carrying on what SITE did as far as adult education is concerned. And EduSat, somebody mentioned, which is all about taking on the education TV, which we started with SITE, beyond the 1 hour per day kind of thing. And in both the GramSat and EduSat, one of the interesting things which we did was to have a feedback, a talkback, which could either come on the phone line or could come through an inbuilt technology, right? SITE did not have this, and this was thought to be something that's very important. But today, of course, all these are old hat. Today, in fact, everything is going through DTH. There are something like 40 or 50 channels which are covering various aspects of education and health and so forth through the government DTH channels, which are broadcast every day. But the real thing now, of course, is through internet. Now, there is a little problem on the internet. We'll discuss that later. But if you want to reach very remote areas, then where the normal wireless internet does not reach, or even the wired internet does not reach, then there is no other option but to take it to satellite. And a new class of satellites have been developed, which are called the high throughput satellites, or HTS. So here is a typical Gramsat channel. It was also called the Training and Development Communication Channel. And here you can see the way it works, that you have a studio at the teaching end, which signal is transmitted by an earth station to typically an INSAT satellite, and then you have three ways of receiving it. One is again using the same what we call the direct reception system receivers attached to a TV, and these can only receive, you cannot talk back. Then you have another set of terminals which are also including the talkback part. So actually these antennas are two-way antennas. So you have one-way TV plus audio, and the other is audio only, the return audio. Then you can have a more complex system where you have the talkback going through the email or through a fax machine or through even an email on or a standard telephone voice. So this was replaced by what we called as the EduSat network. Now this was a much more complex system because it operated in a higher frequency band called Ku band. And here again you had these kind of special devices. You had the receive-only terminal, which you can see at the top right, and then you have the return, the talkback system, which is a slightly larger antenna. And then you can have talkback with video, which is a little bit more complex, and so forth. At the same time, the old system is also continued on the EduSat network. So this is how basically we were able to continue with the distance education program, specifically now aimed at not just rural areas, but to schools, to colleges, and to universities. But I mentioned to you the problem of getting an internet through the satellite, right? So internet really provides the easiest form of interactivity, and you are all aware of that. All of you are internet users. You can use your internet even on your mobile phone, and you don't need any special technology or special hardware or anything of that sort. You have a mobile phone, which is a smartphone, fine. You get onto the internet, and then perhaps many of you are watching this program like that on YouTube. But the problem is that the connectivity of the internet in our countries, particularly in Asia, Southeast Asia, and also in countries like the northern part of Canada or the eastern part of Russia, which are very sparsely populated, you do have problems of getting internet into those areas, and you have no choice except to go for satellites. So that's where the high throughput satellite comes in. But then there is a problem with the satellites, which are all 36,000 kilometers up in the space. And the problem is what is called latency. What is latency? Latency is nothing else but the delay. So in a normal internet, how you start is you connect to the internet, and then actually you start with a lower bandwidth. Then as the system sees that it can tolerate more and more bandwidth, it goes on increasing the bandwidth until you are achieving the full bandwidth of your system. In a satellite system, how does this happen is basically it looks at how good the return signals are coming. For every packet of information which the transmitter is sending, and the receiver sends back an acknowledgement packet. So looking at that acknowledgement packet, it decides on the strength of the network. In a satellite system, what happens is that since there is an inbuilt delay from the satellite of about half a second, so that is too much for the internet, and the internet actually shuts down. So you have to do a lot of other tricks to be able to use internet over the satellite. So therefore, what happened was people started looking at the different satellites, and what you see on your left is a very simple, ordinary kind of what we call as the bent pipe satellite. Imagine that you have a lit pipe up in space, so you are pushing a signal up into the pipe from the ground, and the satellite is simply strengthening that signal and sending it back to you on the ground. The difficulty with this is that the entire bandwidth of the satellite, which typically could be about 36 megahertz, is totally used for the entire region of the coverage of the beam. So actually, therefore, you cannot really have very good high-speed internet. The trick is then not to have one bent pipe, but have a couple of bent pipes. Okay, So if you have a couple of bent pipes, then what happens is the frequency gets reused. So you are able to use the same frequency for two different locations, right? So that gives you a little better, use of the frequency. But if you go to a new class of satellites, which we call as the onboard processing satellites, the interesting part is that the satellite has got a kind of switch, like in telephony, you have a switching system where as you dial the number, you get connected to your whomever you're trying to contact. This satellite also has a similar system, except that it works on both audio and video, and therefore a person or a group of people can actually link to that satellite, link to the desired group through the satellite. Therefore, you are able to have very good use of the bandwidth, and therefore you are able to really give the kind of high speed that you require in an internet, right? So typically here is what a beam pattern looks for the coverage of India by one of the I think it must be GSAT 17, but I'm not very sure, so don't take my word for it. But one of the more advanced GSATs. So you see each beam, and you see each beam can use a particular frequency, and then you can reuse those frequencies so long as the beams are not touching. So, for example, if you have a beam for the northeast, you can use the same beam in Kashmir. You can use the same beam down south. In Kerala or maybe in the Andamans and so forth. So this way you are able to reuse the frequency, and so you are able to provide a much higher bandwidth. So this is a way in which you are able to transmit internet type connections at high speed to the country. But the real solution is coming up today, and that is what is called as the medium Earth orbit satellites, right? MEO. And I think you will be having people who will be talking to you about some of these satellites. There are a lot of private entrepreneurs in India who are getting into this game. What is the benefit of this? Well, because you're not at 36,000 kilometers, but only at 8,000 kilometers. So therefore, the latency is automatically reduced, right? So you have no latency problem, so you can get your bandwidth. But you need a constellation of satellites, because a satellite at 36,000 kilometers appears stationary above a point on the Earth. So that's why you can use it for communications and so forth. But if you have a satellite at a lower orbit, then its position is changing with respect to the Earth. And therefore, you will have to have a very complex system on the Earth. It's not difficult, given today's advances in communication technology, to be able to track these satellites. And actually, you may perhaps be able to use this on a standard mobile, right? And there are two groups of satellites which are already in. One is the Starlink from SpaceX, which you must have heard of. And incidentally, the astronomers are very annoyed with Starlink because they're spoiling the observation field, because you can see the streaks of the satellites going across. So they have to now make those satellites less reflective. Another one is the OneWeb, which is going to come up. And incidentally, there is an Indian interest in this, because a part owner of the OneWeb is the British government, and the other part owner is Bharti Airtel. So, okay, so that's enough about the communications part of it. The other part I want to talk to you about is basically the remote sensing, or shall we say it's the geospatial, right? Because remote sensing only one aspect of geospatial. There are many other aspects. For example, the global navigation satellite system is also a part of the geospatial. A lot of things are there which are not necessarily on satellite, like drone imaging and so forth. These are also part of geospatial. So I'm going to use the term geospatial. I'm not going to use the term remote sensing, but please understand that remote sensing is a subset of geospatial. So what do you do? Basically, geospatial is try to solve spatial problems, right? I think Nikita talked about, the water problem, the urban growth problem, and things like that. These are all basically spatial problems. So you try and solve those problems. And then initially we started with a lot of different hardware, different software. Then you could bring in a lot of compatibility between them. Then the interesting thing that happened was that you had a technology called geographical information systems. You had a technology called the global positioning system, or GNSS. You had mobile communications, and you got these all together. And what do you have? You have your Google Map, right, on your smartphone. Your smartphone has a GPS receiver which calculates your location. You have your internet on your smartphone, which brings in the corresponding Google Map, and there you are. And now you can use it for finding points of interest. You can use it for navigating, going from point A to point B, so many other things. So this kind of convergence is something that has helped a lot. Then, of course, WebGIS is another technology which got developed and which is very, very easily accessible to the users. And then today what we are seeing is that we have integrated just geospatial systems with information technology, with e-governance, with ERP, and so many other technologies. So basically, convergence is bringing in a lot of applications. But the point is that all the applications that you see today are essentially global, right? So because you get a synoptic view. What's a synoptic view? You can see a large region in the same picture, right? So that reduces your cost of your data collection. But the problem is that this starts giving you a universal prescription. And you cannot segment it by community requirements or even individual requirements. So in these kind of systems, the end beneficiary, the person who's going to use, okay, he is passive. He is there to receive all your gyan, but you cannot use his gyan which he has, and that's where the local view comes in. So in the local view, what happens is a lot of local information is available. One of the technologies which you use is called rapid rural appraisal, and this brings out a lot of the local knowledge. Most importantly, then the local people have a voice in the decision making. They can participate in the decision making. And third thing is that the local view avoids the high cost of remote sensing and GIS and all these fancy technologies, right? But you need both. So how can you do that? So how do you develop a strategy, therefore? So how do you develop a strategy is that you start looking just beyond serving up maps and applications on a server. What you start looking for is really the decision making that people have to do. And then you customize your service so that even it can make sense to even one individual, right? And one thing that's very important to understand for those of you who will be getting into this field or who are already in this field is that customer needs are very latent. What is the meaning? That the customer cannot really verbalize what he wants. He may know what he wants, but he is not able to put it in words. So we call that as a latent need. So you have a latent need, and the latent need has to be understood and turned into a felt need, right? And once the customer now understands what he would like to have, then what you do is you start looking at what are the business opportunities. And these, you are to look at this, you have to look at what is available, right? So you can call upon a range of technologies which are available, right? There are new technologies, there are available technologies. All this feeds into your business opportunities, and from there you are able to strategize how to approach. So is it a farmer insurance problem that you're trying to solve, or is it a farmer optimum land utilization you are trying to solve, or is it a person who's trying to buy a house, how best to select that house in among the new housing colonies? Is that what you're looking at? These are the kind of things that are really individual problems, and these are the kind of things which require a kind of service which is unfortunately not there today in a mature manner. There are many efforts which are going on in this direction, but they are not yet mature. So this is a great field, a great opportunity which is available. So let me talk about a little bit more about how do you innovate these kind of solutions. So this is a very interesting model which is suggested by late Professor C.K. Prahlad. And the problem was that today we are working on what is called as the Model T Ford paradigm. Model T Ford paradigm is what? Mass production. Look at specific customer segments and customize it in en masse for that particular segment. So you want a very cheap car, okay, costing some affordable to the most common man. So how do you build it? and you use mass production techniques to build it so that the cost goes down, and then you roll it off in hundreds and thousands and millions. Then you might have heard of something called the Model T Ford, which was a roaring success and which actually brought automobiles into the hands of the common man. But this is not good if you want to customize, you want to you want to innovate for an individual. So here is his theory. He says co-create a personalized experience, right? So that means if you have n becomes equal to one person, right? And then you collaborate between companies. That means essentially you collaborate, you bring in all the different technologies that you may have. So G represents the global available technologies, and R represents the part which you require to be able to do the customization, right? And then it's a very interesting equation which he puts. He says that R equal to G means collaboration of globalized resources. And on the other side, you have N equal to 1, which means that is the customization for each individual. And so add the globalized resources to connectivity using digital data delivery and even social networks to be able to customize for each individual, right? So now you see the connectivity that is there between something like geospatial and something like communications, right? And that's why in my talk, I wanted to talk about both about communications as well as about geospatial technologies. So this is I'm not going to go into this diagram, but this is really the kind of very Sarkari model of national spatial data infrastructure. All the big things are there and all. But if you look at the right-hand side and applications, what you see are the very global kind of applications: real estate management, physical planning, environmental protection, and all that kind of stuff. There's no scope of innovation and individualization, customization over there. On the other hand, this is the bottom-up model. This is what we call the non-governmental agencies called the PP model, right? The participatory programming model, right? In this, they call something called resource mapping. What do? Is they sit down with the people and they actually draw the map of the area. But it's a very, ordinary map. It's not to scale. It uses all the terminologies which are basically, local language and so forth, right? But then this has a lot of rich information, and particularly with this kind of information, a lot of customization can be done. So therefore, how do we go ahead? So we talked of the resource collaboration, right? So we collaborate between top down, that is remote sensing, GIS, and decision support on the one side, like collectors and so forth. And on the other side, we have the bottom up, which is the community information which is available, and then the plans which are made participatory through the stakeholders. The stakeholders here are the people right on the ground, the grassroots, so to speak. Okay. And so what you do is, this is where your challenge is. How do you hit the bullseye? That is your challenge, right? So how do you bring this all together to create a system which can apply to even a single individual's requirements? So you have a lot of things in your hand. You have high resolution satellite data, which particularly for rural areas. You have maps, village level maps called cadastral maps. These are now being registered to satellite imagery. In fact, you can get them from Survey of India. A lot of digital databases on household level data. You can get it from Census of India and many other resources. And then you can also get what is called as the ground truth. That is what's really on the ground, using simple devices which can be handled by the portable devices can be handled by the village level. In fact, I am also working with an organization called Foundation for Ecological Security, and in fact, they have developed a little technology which is on a tablet, which is helping them to use land and water resource management at the ground level, so that these people just give it to the end user, and the end user goes there and looks at it, inputs some data into it. Finally, it is uploaded into the main server, and from there a lot of solutions which are possible for that particular field of that particular owner can be supplied, right? So this is for some of the things that are happening. Weather is a very important issue, and automatic weather stations are very much in the news. In fact, there is if you have heard of SkyMet, which is a private company, and they have weather stations almost all over the country. And in fact, today, if I want to know what is the weather in not only in my town but in my area, I can get that from the automatic weather station in my area using a simple app which is there on my smart phone. Sensor networks is another very big and very important source of information, which is now being used for many things, like, for example, collecting soil moisture data, for collecting, it's really a part of the digital weather information, but it goes more, because then you can use it for many other data sets, like soil moisture, which a weather station will not give you, or for that matter, number of traffic on a road, or the how much of solar light is falling on a particular area, and so forth. So customization is, I think, two most important things. One is 24/7 online resources must be available, and available in the local language. Today, everything is in English. There's no help to a person on the ground who may be more familiar with Hindi or Marathi or Telugu or whatever. So you cannot have online resources which are talking in English. You have to have it in local language. And as I said again and again, I keep repeating it, is that decision support has to be provided to the individual. Okay, not even to the community, but to the individual, so that they can look at the natural resources at their command. They can look at their own economic capability. They look at in the context of market intelligence, what will help them to maximize their profit from whatever they grow. And this is what is a customization for every individual. And in terms of delivery, for example, I said custom applications, local languages, it should be interactive. And there are a lot of technology solutions which are there: cloud computing, big data analytics, distant deep learning. So all these are methods and technologies which are available to you. One important look we need to look at is in terms of social networks which are organized for the people, right? For rural audiences, we need to collect and collate and store the traditional local languages which are available. Many people, local knowledge which is available. Many people are doing it, but this needs to be made into a standardized database. There's a lot of information available in the rural agriculture research institutes. In fact, during my working life, I had opportunity to visit quite a few of these agriculture research institutes as part of different projects, and I came to know that there are tons and tons of research reports which are just lying, collecting dust in their archives, and God knows how much of information is there which could be really useful in today's world, where everything is becoming very, very, very costly, expensive, and also not easily available. So then another point which you can look at is, can we provide communications between the farmers and their extension workers, who are usually in touch with the rural agriculture research institutes? This is something that is possible. I mean, can you have a kind of WhatsApp group meant only for this people, or maybe some sort of a social network but not Twitter, but like Twitter, which is developed in Indian languages and which can be very specifically focused towards the requirement of this kind of community. So thank you very much for patiently listening to me. I am open for questions, suggestions, and even if you feel like that, a few brickbats. Thank you very much.
Thank you very much, Professor. It's amazing to know your views on this whole satellites application, and I mean the pictures that you were using in your slides. It just makes us feel that it's not something new, that was there long back, and it's very insightful. Thank you so much for that wonderful session on the topic that you mentioned, taking space applications to the grassroots, like literally to the grassroots of water management, land management, be it the education, distance education that we talked about today, or all the things that you mentioned. I would like to thank you on behalf of all the audience, in fact, the whole SSERD team. Thank you so much, sir. And dear audience, in case if you have any questions, do post it so that we take it. Um, so we have like few questions. I mean, like they're very general questions, but I would be taking only the things which I think you should answer. Um, yeah. So there's a question which says little more about geostationary satellites. If you could answer.
Okay. Basically, what happens is, I'll take off from what one of you talked about, throwing the stone in this, throwing a cannonball in the sky and making it go around the earth. Okay. So if you throw a cannonball, it goes up to a height and then falls down and it chases a parabola, right? Now, if the speed of the cannonball can be made so fast, like something like 7 kilometers per second, then what happens is that it doesn't ever fall back onto Earth, you see, and it keeps going round and round and round the Earth, right? Now, the higher velocity that you impart to the satellite, the higher it goes up into the orbit, right? So if you can give it a velocity which will take it up to about 36,000 kilometers above the Earth's surface, then the angular velocity of the satellite and the let me not talk angular velocity, let me talk the rotation of the satellite and the rotation of the Earth matches, which means basically both are rotating at the rate of 1 revolution in 24 hours, right? So therefore, then what happens is that satellite is looking like it is stationary on the surface of the Earth, right? Actually, it is not. It's going at a tremendous speed. Okay, at 36,000 kilometers away from the Earth, is going at a tremendous speed. But the speed is matching the speed of the Earth's rotation. So therefore, the satellite, from an observer on the ground, the satellite looks like it is stationary, and that's why we call it a geostationary satellite. And it has to be over the equator because the Earth is rotating about its north and south pole, right? So it goes around at the equator, and so the satellite is also around the equator. And that's called a geostationary orbit.
Thank you very much, Professor. This second question and also the last question. What kind of materials do we use for satellites, particularly that go to space? I think they're more specific on what kind of metal is what they're asking.
Well, weight is at a premium in a satellite, right? Because the more weight you add, the more power you need on your rockets, right? So you want to put more useful things on the satellite, and but you need a structure, right? So one of the main things that people have been using is one of the lightest metals they can think of, which is aluminium, and also it's made into a what is called as a honeycomb shape. If you've seen a honeycomb, no, you have a lot of holes, but the honeycombs are very strong. So this kind of honeycomb structure is used for most of the satellites. Now, of course, there are so many other materials which have come up. We used to a lot of these what do you call these resins, the reinforced resins and things like that. They are being used for the antenna structure, antenna dishes, for example. So, there are a lot of new materials which are coming up. In fact, today people are even talking of, what we call that 3D printing of these. They're even 3D printing rockets, rocket nozzles and things like that. So there are lots of materials which are coming up, new materials which are coming up. Basic thing is they must have good structural strength and they must be light.
Okay, sir. We have another question. If you could, that's a interesting question, really interesting question. If you could answer that. This is the last question we'll be taking in from the YouTube chat. The question says, how does the satellites send data to the receivers, and what sort of languages they use to communicate with each other?
Well, they're basically using digital technology, right? So what you have is you on the satellite you have a a digital encoder, because the signals that are coming from, typically, let's say, a remote sensing satellite, the sensor is an analog sensor, but the data that comes out has to be converted into digital. So you have analog to digital conversion, first of all. Then what you do is you transmit the digital signal by putting it on a carrier. Normally, one uses fairly high. There are frequencies are all allocated by the International Telecommunication Union. Typically, you use the you can use the UHF, you can use the S band, you can use the X band, the KU band, KA band. It all depends on how much of bandwidth you require. Typically today, remote sensing satellites are using the X band. And what is done is that these digital signals are first encoded onto the carrier, right? And this is digital encoding. I will not go into the intricacies of the digital encoding, but suffice it to say that you have to encode it, encode the carrier. Now you have a Earth station which then receives that signal. It actually has to track the satellite, and because this is not a geosynchronous satellite, these are essentially what we call as polar orbiting satellites. So the Earth station antenna tracks the satellite, receives that signal, right? Then it demodulates it, gets back the digital stream, and then the digital stream is then converted into whatever product you want. For example, it can be used to write an image, so it basically converts the digital into an analog form, or it can be put onto a device like a CD, and then you have the original data in digital form, which you can then use it on your computer. Does that satisfy?
Yes, sir, sure, sure. Thank you so much. You gave us a whole new insight towards how space technology are, how we have distributed it amongst different classes of people, like of where it actually needs to be strengthened, like the space technology at which particular point and how which particular section of the society needs more of space technology, and how we can get space technology to the grassroots, that is the farmers and the fishes and the people from the villages that are backbone of most of all of the nations. Thank you so much for giving so much insight, and I really like the part wherein you explain about the top-down approach and the bottom-up approach, and how we talk about bringing in data from both these sides to collaborate into the geographic information system, the GIS system that we have, like the kind of methodologies that we use there. Thank you for shedding so much light upon all these topics. Thank you for joining us today. We're glad to have you, sir, and that was a wonderful keynote. Thank you. Okay, so please don't leave right now. I'll be briefing you all about the schedule for the upcoming week, and there will also be briefing about the competition. All of you had queries regarding the competitions and workshops. So right now, I'll be taking you all through the schedule that we will be following throughout this week. So for tomorrow, we have a keynote on remote sensing by Awais Ahmed, founder and CEO of Pixel. So this keynote is scheduled at 5 o'clock tomorrow. So from 5 to 5:30, we have a keynote on remote sensing by Mr. Awais Ahmed. And it is followed by another keynote by Professor J. Srinivasan on understanding weather and climate through satellite. This is scheduled from 5:30 to 6:30 p.m. Professor J. Srinivasan is a distinguished scientist from Indian Institute of Science. So at 6:30, we have a workshop scheduled for you all. The workshop is on remote sensing satellites and optical image processing by Marcelo Fernando. So this is the schedule for tomorrow. Likewise, on 6th of October, that is Tuesday, we have a keynote on satellites for astronomy and exploration. So it is about AstroSat, the satellite that ISRO had launched to study the astrographic pictures for particularly for astronomical studies. This keynote will be taken by Dr. Annapurni Subramanian, Director and Professor of Indian Institute of Astrophysics. This is on 6th of October at 5 o'clock. Then at 5:30, we have another keynote on Earth observation by Prateep, who is the co-founder and CEO of the company SatShaw. So, and at 6 o'clock, we have a workshop scheduled for you. It is about the applications of geotagging and how geotagging can be done using your phones at your place. We also have a small activity planned during the workshop, which you all can do sitting right at the comfort of your place. And I'll be briefing about the competitions after briefing about the keynotes. So please stay with us. Then on 7th of October, we have another keynote at 5 o'clock, which is on environmental monitoring through the Earth observation data by Abhilasha Purwar, founder and CEO of Blue Sky Analytics. Then we have another keynote about communication and navigational satellites by Devlina, CEO of Numerate. This is scheduled at 5:30 on 7th of October. Then on 8th of October, we have a keynote by two distinguished people from Kava Space, Mr. Rishabh Chaturvedi and Mr. Sanket Downkar. The keynote is on making space data accessible by accessible. So as Sir Arup sir was talking about, you know, getting all these space data to all of us, how to get all these space data. So this talk will be about that. Then there is another keynote which is scheduled at 5:30 on the very same day about remote sensing and supporting the sustainability of Earth's finite resource. This is by Dr. Praveen K. Thakur, who's a scientist at IIRS ISRO. Then we have another workshop at 6 o'clock. From 6 to 7, we have a workshop on real-time tracking of satellites. So as Arup sir was mentioning about, how Starlinks have, become a nuisance amongst the stargazers. So if you are interested in tracking at what particular time and what particular place will you be able to track International Space Station or a particular satellite that is visible in your night sky. So tracking of all these satellites, it will be taught during this particular workshop, which is on 8th of October. Then on 9th of October, that is Friday, we have 3 more keynotes scheduled on this day. The first keynote, which is to occur at 5 o'clock, it is on challenges and opportunities in satellite-based industry by Mr. Narayan Prasad, who's the CEO of SatSearch. And at 5:30, we have another keynote on space communication network and interplanetary internet by Mr. Nitish K. Singh, co-founder and CEO of Astrogate Labs. At 6 o'clock, we have a keynote on interstellar gases. Most of the astrophysics enthusiasts, you would be curious about this particular topic. So watch out for this. There's a keynote on interstellar gases by Professor Jayant Murthy, who is a senior professor at Indian Institute of Astrophysics on 9th of October from 6 to 7. And on 10th of October, we have a mega workshop. Okay, this mega workshop is by Danny Source from Open Cosmos. The workshop is titled Space Mission Design. So please, don't forget to tune in for all these events and programs and the keynotes. We'll be having the valedictory ceremony on 10th of October, Saturday, from 5 to 7. Do join us then. And regarding the competitions, Satellite X competition will be commencing today. The problem statement and the template that you all have to use for Satellite X submission report making will be posted in the SSERD website for World Space Week, wherein you have the instruction section. So we'll be placing the template as well as the problem statement there, and we'll also be sending out the problem statement and templates to students and participants who have already registered prior. So if you haven't already, please do go select the register link there in the website, register there, and the templates are available there on the website. It will be made available post 8 o'clock. So do go download the template, and you have time till 8th of October for the submission of Satellite X report. So the problem statement will be, you can find the document for the problem statement there. Next, we have the Guardian Knot event, which will be commencing from tomorrow, which is the treasure hunt. So for this treasure hunt, the briefing of this session will be carried out tomorrow at 7:30 p.m. So we'll be briefing about how the treasure hunt will proceed and how you can access the clues for this treasure hunt. So if you haven't already registered, it's okay. You can still register. The link is there up in the website. Go there, go now and go register for the treasure hunt. It's gonna be really fun. The Guardian Knot, which will start from tomorrow. So we have Celestial Quiz again, which is on 6th of October. The topic for the Celestial Quiz will be announced on 8 a.m. on 6th of October in the instruction sections there in the website. So please do check out, keep frequently checking out the instruction section there on the SSERD.org/WSW 2020 website. So we have the Sphinx-Light, which is the space quest on the satellite technology and space technology on the 7th of October. So this particular contest is open for grade 8 to grade 12. So if you are interested, please do go register in the site. So for this particular event, which is Pinks to Light, the links for joining into the quiz session will be shared to only those people who have registered there on the website. So we'll be sending in a code link there on 7th morning. On 7th October morning, we'll be sending in a join link using which you are supposed to join on the quizzes platform sharp at 4:45. The preliminary quiz will commence sharp at 5, and the quiz session, the prelim session will end sharp at 5:15. So whoever would have topped in the preliminary session, despite whether you have completed the quiz or not, so from 5 to 5:15, who would have scored high will be selected for the next round, which will be happening on the same day at 7 p.m. So next we have Estella Palette, which is the poster making contest. And again, the topic for the same will be announced in the instruction section of our website. So keep watching frequently. Keep checking the instruction section frequently. So the topics will be announced at 8 a.m. on 8th of October. You have time till 9th of October now at 8 p.m. of 9th of October to make your submission through the submission link, which will be provided in the instruction section. And regarding the Star Wars, which is the virtual debate competition that we are holding, the preliminary link, the Google Form link, will be shared to you all post 9 o'clock today. So all what you have to do is you have to state there's a topic which is given in the Google Form. You have to read out the topic and state your opinions for the topic as well as against the topic within a word limit of 50 words for each, and you have to submit that particular response. So participants who have made very good arguments will be selected out from that list, and the finals will be held here on 9th of October at 6 p.m. IST. So the Star Wars is open for junior college students, that is the 11th graders and 12th graders and undergraduate students. So I hope you all are clear with the doubts regarding the competitions. So the links regarding the competitions will all be sent out today post 8 p.m. and 9 p.m. Please do check out the mails and keep checking out the instruction section. And also regarding the platform, you all have logged in, all of you who have registered for this event. This is a free event. So all of you who have registered, for you, we have sent in a platform wherein you are to log in. I'll be showing you the platform right now. I'll be presenting you what sections are there present in the platform. Okay. So let me log out. Okay. So this is the page where you'll be directed to once you enter into the particular site wherein we are hosting this particular World Space Week event. So you'll be, if you are entering for the first time, you're supposed to go and register yourself here. You'll be requiring to enter your mail ID, after which you'll be sent in a verification link. After you completing the verification, you can set the password and come back here to log in again. So I'll be entering my mail ID and okay, I'm logged in. So as you can see here, day one, we have the inauguration and welcome speech session here, which requires me to join in for the session. And keynote again here, which was by Professor Arup Dasgupta sir. So yeah, the join in link is also present here. For Satellite X, as we are not hosting any particular session right now, so this link is kind of blocked. So there is no live relay session. This is an offline event that is you all making reports, which will be occurring for 2 to 3 days. That is from 4 to till 8, wherein you will be making report based on the problem statement. So there is no join-in session where the briefing would happen. So this link is not described. And we have the schedule tab here, wherein you can find what are the programs scheduled for day 1, day 2, day 3, day 4, day 5, day 6, and day 7. You can select no more, wherein again, as these sessions are not yet scheduled, you find that these links are kind of freeze. They are not active yet. So on the day of the event, the join-in links will be activated. So you can use this particular platform to watch those live sessions, those live relays, and also the previous space talks conducted by SSERD are available here. This is one of the space talk on nanotechnology by Gadadhar Reddy, which we have made available in this particular section, and previous space talks on our YouTube channel. And also do go watch our YouTube channel, and don't forget to subscribe there. There are a few amazing videos regarding space science and technology that have been uploaded there. So we keep having space talks and by many distinguished people, professors, and lecturers, scientists out there. So do check out all these videos and subscribe to our YouTube channel. And we have Edge of Space, which is our blog website, wherein the contents related to latest developments in space technology are updated here. We have many young writers, writers on astronomy and space technology, undergraduate and high school students, junior college students who write for this particular blog. So do go check this blog out. And so yeah, we also have an internship division in here at SSERD called as the IPD. So as Nikita was mentioning about the projects that we are doing here, right now the applications are open for batch 5 students. Here we work with respect to various topics, and satellites happen to be one among the topics, one of the topics that we work here in the IPD. So do check out the internship project division and few of the older projects that are done by the previous batches here in the IPD section of SSERD website. And we have the sserd.org WSW 2020 website, wherein the details regarding the competitions will be posted. So if you haven't registered for this particular website, so you can go here. You have the registration link, which will direct you to the platform which I demonstrated to you right now. So we have a brief introduction about our SSERD, and these are the various competitions that we have. So keep checking out the instructions frequently. So the instructions will be updated frequently, so that this would serve as a medium of communication between you and us, as all of the competitions are happening virtually. And if you do have any queries regarding any of the competitions, what we would like you to do is go to our Facebook page, go to our Instagram page, follow us there, then search for the post regarding these competition, and in the comment section do post your question, and we will get back to you as soon as possible related to any queries regarding these competitions. And do keep checking out the instruction sections here posted on the website. And the schedule is also posted here. The full program schedule is also posted here on the SSERD website. Do check it out. These are all speakers with whom we'll be interacting throughout this week, celebrating the saga of satellites. I hope you all are clear with the workings of our program for the World Space Week. Thank you all for joining in, and thank you for making this event become more successful. And we hope to look you all forward in the upcoming keynotes and workshops. Do join us there and enjoy and celebrate this saga of satellites along with us during this World Space Week 2020. This is Tejas KV signing off. Bye.